Welcome. This is Coach Dorf. We're in section 3.5 and we're looking at a homework example. In this example, we need to find the second derivative of a function that the x's and y's are mixed together. So we're going to need to use implicit differentiation. To do this problem, the first thing we will do is find the first derivative. So first, find y prime, which could also be written as dy dx. To do that, we're going to do d dx of both sides of the equation. So we do d dx of the left-hand side and d dx of the right-hand side. On the left-hand side, then, we're doing d dx of x squared, which would be 2x. And then we'd have a dx dx, which we can leave off. And then we have 8y. And because our variable there is y, we have a dy dx. On the right-hand side, we have d dx of 4, which is a constant, so that equals 0. Now we want to solve for dy dx. We want to get dy dx by itself. So we can bring the 2x to the other side, to the right-hand side by subtracting it. And then we're going to divide both sides by 8y. And we end up with dy dx equals negative x over 4y. Now, this is not our final answer, but this will be an important result. Now, we found the first derivative. What we really want to do, what we're supposed to do, is find the second derivative. So we notice then that y double prime, the second derivative, would be the derivative of the first. So I'm going to do d dx of dy dx, right? The part that we just found. All right. Or in other words, it's taking the derivative of negative x over 4y, okay, because that's what we just got right here in the previous part. All right, so we have y double prime equals d dx of negative x over 4y. Now I look at that, negative x over 4y, and if I'm taking the derivative of that, I have to use the quotient rule because I have a numerator and a denominator part. So the quotient rule says I take the derivative of the denominator, I take the denominator, and then I take the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. All right, so that's going to give me a 4y. Now I take d dx of negative x, and that's going to be negative 1. And then I have a negative x, so that's going to be a plus x. And then I do take d dx of 4y, and that's going to be 4, and the dy dx all over. I'm going to go ahead and simplify 4y quantity squared to be 16y squared. Now, what do I do here with this? I have this dy dx. Well, we're going to use what we had earlier and substitute that in. So we're going to get negative 4y. So I'm going to multiply my negative 1 times 4y plus 4x times, and now I put in what I had before, this negative x over 4y. Again, that part comes from substituting in what we had there, and that's all over 16y squared. So if I simplify that, I have negative 4y on the top minus 4x squared over 4y all over 16y squared. I can cancel out my 4's here. And what I'm going to do is I have a y in the denominator of the numerator. So in this last part here, I've got this y here that's in the top. If I multiply top and bottom of the fractions by y, that will get rid of it. So when I do that, I get this y times the negative 4y will give me negative 4y squared minus x squared. The y's disappear because I have a y, that red y on top, divided by that y in the y circled in red on the bottom. So those cancel out. And in the very denominator, the very bottom denominator, I have 16y cubed. Okay. I'm going to rewrite that one more way. I'm going to factor out a negative sign. And so then I have 4y squared plus x squared with a negative factored out in front and the 16y cubed in the denominator. And then I go back and I say, well, wait a minute. That looks familiar, this 4y squared x plus x squared. When I go back all the way to the beginning, I see that 4y squared plus x squared equals 4. So this equals 4. So then I have negative 4 over 16y cubed. And then I can reduce that 4 and the 16 to get negative 1 over 4y cubed. And that's my final answer. Hope that helps.